Okay, so I said these are day 4, and I can do this. Yes, start editing on your projects. So what you're going to need for this session is the Rust installed in your machine. Again, this was done quite previously. Then here are some of the things we're going to cover in this session. So we're going to look at enumerations in Rust. We're going to look at structures in Rust. We're going to look at traits. And now, enums, I think you guys are familiar with this, with the concept of enums. Structures, if you're coming from JavaScript, is what we have as classes. Traits are what we have as interfaces in JavaScript. Then you're also going to learn how to write unit tests in Rust. So how can you write a unit test or test your program in Rust? So great, let's take this away. So I'll just go ahead and share. Let me share something. Yes, so in our day 2, that is our class yesterday, we went through, okay, we finished up with the loops previously. Then we went through strings, we covered strings, we talked about arrays, we talked about functions, and we left out references. So this is where we're going to begin or start off our session. Then you're going to proceed with enums, structures, traits, and then unit test, and we'll be done with the session. So really hope this is going to be brief, and today we're going to really move on quickly. Okay, so reference pointers point to a resource in memory. Think of pointers as you're having, let me see. You have a value within your computer memory, right? And like we said, the value within your computer memory is held in a variable, okay? So the variable is the named computer memory. So the value is within a computer memory somewhere. Now, if we wanted to retrieve that value or to access the value, then we need some sort of way of referencing that value. So in that case, we need to use to reference the memory address for us to be able to get to that value. Okay, so that is exactly what you're going to cover here. So the concept of all that and how it is captured in Rust. Now, the way this behaves is a bit different with the kind of data or data type that is in question. So for instance, I'm just going to work with a very primitive array right here. I'm just going to call this array, and we're going to have that I'm going to declare it as it appears in line 6. Now, if I wanted to come down here and have array 2, then I simply assign array. So in this case, what I'm simply trying to do is in line 6, I'm storing this array in this variable. Then in line 7, I'm creating a new variable, but then I'm assigning the value of array in line 6 as its value. So in other words, it is going to contain what? This same array, the value of this same array, okay? Now, if I come down here and let's say we want to print this out, I think I've not configured this yet in my mod.rs file, so let me just make that change right here. Let me bring it in first of all, have that commented out, and just execute the run function. Great. So that is it. Now, if I come over here and let's say we want to, let's display array 1. Okay. Okay. We want to display, what have I done now? We want to display the array. But what's happening with me today? Okay. So we want to display this array. So I'll just go ahead and execute this in my terminal. I'm going to do cargo run. And I think things are still loading from my end, so that's why the delay is there. Great. So if we print array, in this case, the first array in our terminal, it gives us the array we initialized, 1, 2, 3, 4, 5. Okay. And if we go ahead and print array2, the variable array2, it should give us the same information. Okay. So I'll just go ahead and do cargo run, and you realize it is giving us that same information right there. 1, 2, 3, 4. So what happened behind the scene? For primitive data types, and when I talk about primitive data types, I'm referring to integers we talked about while we were looking at types. So the U8, I8, U16, and all that. I'm talking about the literal string or the fixed length string. I'm talking about the fixed length array and the booleans, you know, the characters and all that. So all the primitive data types in Rust, if you are going to reference them, then so in this case, I'm trying to create another variable. Then I want to assign this same value. So what will happen in the memory or in the memory of your computer is this value is going to be copied within your memory. So you're going to have two memory spaces storing this same value within your computer memory. So that is basically what happens under behind the scenes. If I were to come here and say let name is equal to Samson, then over here I create another name, in this case name 2, and assign the same value. What is going to happen is the value Samson is going to be copied, so it is going to be generated twice, okay, within the memory. And the second value, Samson, is going to be assigned to variable name 2. Okay. Now, this is allowed for primitive data types, like I've said. That is why this is going to be possible. However, if you only wanted to, let me talk about that in this second section. So right here, there's a note. This is a note with non-primitive data types. So non-primitive data types these are the data types we refer to as, some of them are the strings, the structures that we'll be talking about today. So the custom data types. These are the vectors. Okay. So these are basically data types that are sort of they are sort of building up from the primitive data types we have. So if you assign another variable to a piece of data, the first variable will no longer hold that value. You'll need to use a reference ampersand to point to the resource. What that means is down here, let's talk about vectors to capture this. So let's say we're going to have what, students. Then students is going to be a vector of names. So we're going to have Samson, we're going to have Paul, we're going to have Lawrence, and the list can proceed. Now, you see with these, with our vector now, we are having a vector that is basically containing string literals. Now, if I came down here and said, let's have candidates, then at this point now, I want to assign students to candidates. So the value under the students variable, I want to basically assign that to the variable candidate. So I'll just go ahead and do that, then put a colon afterwards. Now, I really want you guys to be keen on this because there's going to be some very trick right here. Now, I'm going to go ahead and print the first variable, students, over there. And now you realize it is giving me an error, right? However, at the top right here, we were able to print both the variables. So why is this one giving me the error? The point is, while we declared the variable students in line 13 and gave it its value, in line 14, when we created the candidates variable and assigned the variable students to our candidates variable, what basically happened is we snatched the reference to this value from students variable, and now that reference was given to the candidates variable. Okay, so the students variable no longer has reference to this value right here, to this vector. Okay, so it basically, and this is what we are referring to as the ownership concept in Rust. We can't have more than one variable referring to the same value within your memory. Okay, so we can't have, I think, I know this is very possible in JavaScript. For those of you who are coming from a JavaScript background, in JavaScript, this would probably work. So we are basically having two variables pointing to one value within your memory. Now in Rust, for memory management and security purposes, that is not possible. So you can only have one variable referring to one value at every single time within your program. So if we wanted the candidates variable to point to this very same value and still have students variable point to this very same value, then we'll need to now use the reference. We'll now need to reference this variable within our candidates variable. So whatever is going to be stored in our candidates variable is basically going to be a reference to the students variable, so that through the students variable, we are able to get to the actual value. Okay, I really hope I'm not confusing anyone. So what I'm going to do right there is basically add the ampersand, and you realize the error has gone away. Okay, now I'll go ahead and print these in the terminal. Now you realize that the vector is now printing, and I can go ahead and print candidates as well. Let's see what this gives us. And you realize it gives us the same vector. So at this point, we are printing the same value at one memory location, but through different variables. And this is made possible by the use of this ampersand. So these are reference, it helps us reference values within our program. I'll give us another example or scenario. So say we have name right here, and this time round we're going to use the string object to create this name. So we're going to do from, and let's say we have God right here. Now we have the name referring to God. Down here, I'm going to try and do name2 and assign basically that, assign our name variable to name2. Then in line 19, I'm going to try and print out variable name. Now you realize that our name variable is now giving us an error, and it is telling us that, hey, you're trying to borrow a moved value. So in other words, this value was moved and it is now under name2. It is no longer referenced by the variable name. So if we wanted to print out this value, then we'll need to use name2 variable. and that will be able to print it in our terminal. That way, you realize that that now gives the error away. But if we still wanted to make use of the name variable within our program, even after the allocation, then we'll have to use the reference symbol just before a variable name. And now this, you realize, is just working quite well. So we have that right there printed out. So that is basically it about references. I know yesterday we talked about functions. So how can this be captured in a function? Like I said, guys, if you pass this variable down here, then name2 is basically going to take ownership of this value. And name1, then the variable name will no longer have ownership to that value, and that's why we are having the error. So at some points in your programming, you may come up, you may have a function that is trying to get ownership of variables or values within your program. So how are you able to sort of get your way around that? So let's say we have a function right here, and we're going to say, let's name this greet. So greet is basically going to print some statement right here, and it is going to say hello. Then you're going to pass some variable name over there. So we're going to, this is going to come as a parameter, and it is going to come as a string parameter. Okay. Now I'm going to invoke the greet function within our run function, passing in the name. So what we declared in line 16. Let me just do that first. So I'll do greet. Then I'll pass in name. Let me pass in name2 this time round. Okay, let me pass in name2. Then down here, okay, great. Then down here, I simply want to do what? I want to print out name2. Now, there's an error. So why is the error coming up? Maybe I can have someone try. Anyone who wants to give it a try? Yes, Samson?
Yes, I was about to answer it because of the ampersand.
Yes.
It was because of the ampersand is not present under the before the name.
Yeah, that's a good trial. So the point is, we are having the name, the variable name right here, which we are declaring in line 16, and we're giving it this value. So in line 17, it is basic, while we declare name2 variable, the name2 variable is taking ownership of this value, and name is no longer containing that value. So the name is invalid, or it has been dropped from our memory. It no longer exists. Okay. Then now at this point, I can work with name2 in line 18, and it will just it will just print out well. Now in line 19, our greet function is accepting the name variable, but then instead of accepting a reference to that variable, our function is taking ownership of the value contained within that variable. So what does that tell you? It means that name2 will no longer be valid, or will no longer contain this value. The value will now be contained within our function. So again, at this point, the name2 variable is no longer going to be valid. It is going to be dropped out of the memory. Okay, so that's why while we try using it in line 21, it is giving us what? An error. So what if we wanted to use it as a parameter in our greet function, but then still be able to use it down here? How would we go about that? We would need to come back to our function and pass this as a reference So we need a name of type string, but then we don't need the actual value. We just need a reference to that value. So that's why we're using the ampersand before the type. Then up here, instead of passing the name, we pass ampersand name2. So once or immediately you do that, you realize that the error is gone. Okay. So if I get to my terminal and execute this, now it prints hello guard from our greet function. Then down here it prints guard. Okay. So that is the trick, guys. That is the trick. What if we wanted to change this name within our hello function down here? So let's say you're going to pass in a value, but then instead of that value, we want to sort of make some change to it, then before we print it out. In that case, you need to accept a mutable reference. Okay, a mutable reference. So I can easily come here and say, give name a string. Let's give it this string. Let's give it a different string. So we're going to give it let's give it Samsung. Oh, no. So let's do name.push. Yes. And in this case, we're going to push a string. Then, so at this point, sorry, what have I done? Oh, great, great. So at this point, what we're basically trying to do is we're going to, let's say the user is going to give their first name, then we're going to add a default second name to them or to that, okay? So since our variable is now mutable, I can easily come here and add Alson to that. Then whatever is going to be printed is now going to be hello guard Alson, something like that. So up here, I'll again accept. Now I'll have this variable mutable. Then I'll simply accept a mutable reference to that, to name2. Okay. Now, if I go ahead to my terminal and print this out, we're going to have hello guard Alson from our function right here. Then we have guard Alson. So in this case, we were able to mutate or change the value of name2 right here. That's why this was possible. However, if we just passed it down as a reference, a string reference, but then without the mute keyword, we wouldn't be able to change that value. So I really hope you guys are getting some insights or understanding around that. So that is basically it about the reference, about references. Unless there's any question someone has on this. Yes, Samson, you have a question?
Yes, so I wanted to ask, does the mute before the variable make us able to change the variable, the value of the variable, or what does it?
Yeah, this will.
What exactly does it do?
This is what will, because we said all variables are immutable by default in Rust, right? So if you wanted to change the value or a value of a variable, then you must use the keyword mute. So that's why we are using it at any point in time where we want to change that value. Okay.
Okay.
Yeah.
So
great.
what about the?
Yes.
What about the ampersand? What about the ampersand?
Ampersand is a reference. It basically points to where the actual value we need is without taking ownership of that value. Okay. So let's say this value is in memory partition A, and it's it's apparently referenced by the student's variable, right? So if we in line 14 come in and say, hey, let's assign the variable or the content of the variable students to candidates, then it means that the student variable is basically going to be dropped out of memory, because we can't have more than one variable pointing to the same data within your memory. That will cause conflicts. Okay, so that is why, again, this is a borrowing rule in Rust. That's why we have these reference to be able to do that. And there's also another one, asterisk, which is a pointer that you can basically use to dereference. Now, I'll leave that for you guys to go and read more on that. Okay, but for now, just know that this is how we can go about this. I don't know if that answered you, Samson.
Yes, yes. So also had another small question.
Okay.
Because in the first instance, we were not able to use name2 after the greet function.
Yes.
Let's say we just assign the value in the greet function, we assign the name to name2. We don't change it. Can we still use it in the print line of the greet function?
Yes, we should be able to. So you're saying instead of changing it, so I'll just comment out the line right there. So instead of changing it, we just pass it as a reference that way.
Yes, yes.
Yeah, you realize that you are still being able to print it. Why? Because we are referencing the value. We are not getting the actual value. We're just referencing it. Okay.
So if we passed it without the ampersand, we would not be able to use it after the greet function.
Yeah, that we would not be able, because we are now taking ownership of that particular. We're taking ownership of that particular value, and so it will no longer be available under the variable name2. Okay.
No,
yeah, so that is basically what's happening. It's like you having an object, or it could be a gold, whatever you have. Then another friend is coming in, and it is he or she is telling you that, hey, I want to have access to that particular object you have. And this object can only be owned by one person at any given time. So it means if you're going to give your friend the object or the treasure, you no longer have that object. Okay. And if this treasure was was so worth some good amount of money, or it was very precious, then it means that if you no longer have ownership of it, then you are useless, right? So if we had people going after the treasure, they wouldn't mind, they wouldn't go your way, because you don't have that particular treasure. But if your friend came and told you that, hey, I have some connections that maybe we can use to, get to your treasure. So at this point, you still have the treasure, but your friend is going to market this particular treasure for you outside. So he really doesn't have the treasure, but there's a link between you and him. So he can easily get to you. Okay. So for him to get to that treasure, he has to come through you. He can't go direct to that particular treasure. I don't know if that analogy sort of gave you guys some logic.
Yes, that analogy actually explains it much more.
Yeah.
Much better.
Great. So that is basically
this referencing is specific to Rust. I don't think it's used in other languages.
Yeah, okay.
It doesn't follow the same.
Yeah, what is used in other languages doesn't follow this syntax, because right here we are having this keyword mute that is sort of making things complex. I know, but okay, the reference concept is available in other languages. It's only that the way it is captured in Rust is a bit syntactically different from the other languages. Okay.
Yeah.
Okay, great.
Okay, thank you.
Awesome. So we're now going to move on to today's work. We're going to talk about enums, so enumerations. Now, what are these? What are enumerations? I'm going to give us an example. So we're going to have an enum. So say we have an enum of what? Of a car move. Okay, you can have an enum for a car move. So a car can move forward, right? Car can move forward. A car can reverse, right? Then a car can make a turn, right? So a car can turn left. A car can turn right. Okay. So let's assume this is our enum. So these are moves that we've coded within our program. And we are going to carry out some operations within our program based on the value of this particular enumeration we've just implemented within our program. So this is the car move enum. And within our car move enum, we have some values that are going to control some execution within our program. Now, within my run function right here, let's say we have, let's create a variable, and we're going to name this variable a move. No, move is a keyword in Rust, guys. So I really, I can't use it as it is. I have to bring in some other word, so add something to it. So move car, let me just call it move car for now. Now move car is going to be, is going to make use of our enum or enumeration car move. And car move, now at this point, we're going to specify whether the kind of move our car is going to make. It's either a forward move, a reversal, a turn left, or a turn right. Okay. So I'll just go ahead and do forward right there. So at this point, we've specified that the kind of move our car is going to make is a forward move. Now, down here, I want to print some values based on the move the car is taking. So I'm going to use the match statement we covered previously. I think this was our first session. So I'm going to match the move car variable. So in the event that the move is move forward, just bring this down here. In the case that the car is moving forward, we want to print something, and we simply want to say, now this is going to be a single line statement, so I don't need to use the curly brackets. Okay, so at this point, I'm simply going to print car is moving forward. Okay, then I'll terminate that with a comma. So that is how we separate our cases, using a comma. So in the event that our car is moving, is reversing, okay, so the case that we are reversing the car, we're simply going to print out this and say that, hey, car is reversing. Okay, then again, I'll terminate that using a comma. So in the event that we have, let me just have this copied twice again. So in the case that we have it turn left, car is turning left. And in the case that we have our car turn right, we're going to print this in the terminal as turning right. And what if we passed an invalid value? Okay, We're going to capture that using an underscore. So again, I said this is how you capture default in switch statements in JavaScript or any other language that has that. So I'm simply going to print this out as a invalid input. Okay, great. So let me just now, I think I need to make some changes within my main file. We are now working from day 3 module. So I'll just bring in day 3 module right there. Then comment out day 2. Then down here, I'm gonna invoke the main function of our day 3 module. Like that. Great. So if I go to day 3 module, I still don't have the main function, but I can just do it. Sorry, I can just declare it inside here. What did I do? Great. Then after doing that, we're going to bring in our enumeration file or enums. So we're going to bring these as a module as well. Then within our enums module, we have a function called the run function. So that is basically what I'm going to invoke. And again, you realize that my main function is public at this point. So I really hope you never forgot about that. So within my main.rs file, the error is gone. And back to my enums, I can now be able to invoke this from using cargo run. Great. So right here, we only have the variable moveCar, which has the value forward. So if I print this in our terminal, if we go ahead and run this, let me just do that. You want to do cargo run. So you realize we're going to have car is moving forward printed out. Why? Because the value for our car move was forward. Okay. If let's say I changed this to turn left, then it means we're going to have this statement right here printed out. So that is what we definitely expect to be shown within our terminal. And as you can see, car is turning left. I think my turning was wrongly spelled, so we have that. Car is turning left. Great. So this is basically how we use enums in Rust. There are some other, I'd say, advanced ways that you can make use of enums. There's one popular one we're going to meet while we start talking about smart contracts, and this is the option enum. I'll be sharing something with you that you can read more on that, and just to know how all these are unfolding within the language. But basically, this is how you make use of an enum. We now want to move on to structs or structures. Structures are what we have in other languages as classes. Okay. So structures are basically used to create custom data type. It's just like you can use a class as a blueprint for an object. Okay, so they are basically used to create custom data types or objects within your program. Now, down here, we're going to see how we can create a structure within our program. So let's say now there's a keyword we're going to use, struct, the struct keyword, and our struct keyword is going to, let's name it car. I have no idea why I'm really making use of cars. So we're going to have a car structure or a car class, just for you guys to be able to relate. We're going to have a car structure, and our car structure is going to have some properties or instance variables. So one of it is going to be, let's name these, give this name. And the name is going to be of type string, okay? And then we're going to have model. This is going to be of type string as well. Then mileage. Let's use the 3 for now. We don't want to make it complex. So these are the 3 instance variables that our car structure is going to contain. The 3 instance variables, I've just highlighted are private to this particular structure. Okay, so they are private. So if I try to, first of all, this structure is private to this file. Okay, so in any case, if I try to make use of it outside this file, then I definitely find an error, because by default it is private. So if I wanted to make it public, then I'd simply need to use the pub keyword. So that is basically how we go about that. The other thing is now that we have our car structure, let's see how we can instantiate or create an object from our structure. Okay, I'll just head on to my run function. Let's have the car. Let's have a car variable. Then I'm going to use the car structure. And then we're going to provide the name, in which case it's going to be string from, and this is going to be, guys, can you give me some name? Yes, Mazda. Give it Mazda. Then you have the model. Any Mazda model you guys know? Demio, I hope so. Then we have mileage. Mileage is a 64-bit unsigned integer as captured down here. So what you're going to, let's use 2000. So this car has covered 2000 kilometers mileage. Then you're going to terminate this using the semicolon. Okay. Now you realize that with that, we've been able to sort of structure our car object. So at that point, we have a car object, and we can, let's just print this out as well in our terminal and see what is going to be printed. Sorry, do it that way. Now I said, if you're going to print, the values that are not primitive to the language, so you're not going to print any primitive data type, any value of type of a primitive data type, then you need to use this literal. So that is exactly what I've just made use of. But I'll remove it for now for us to be able to get the error, and you guys, for you to be able to see what we're actually talking about. So inside my mod, I'm going to bring in the structs file. Then I'm simply going to, I'm simply going to execute its run function right here. Then I'll simply comment the enums out. Good. So we have that in place. So the moment you come back here, you realize that, hey, this is giving me an error, and it is telling me that you have a car object that doesn't implement the display trait. Okay. So again, our car was a custom data type that was not implementing the display trait, and that's why the error is there. So for us to be able to go about that, we simply need to bring in the symbols we talked about, so the colon and question mark. But still, this is complaining. Let me see. So it's telling me that, hey, car doesn't implement debug trait. So I'll just go ahead and have it implement that. So this is basically how we go about that. So immediately I do that, the error goes away, and now I can be able to debug my car object. Okay. Let's go ahead and run this in our terminal, guys, and see what is going to be printed out. Awesome. So you realize I have this statement printed out. So it's basically a car object, or a representation of a car as we defined within our program. Okay. That is basically what has been printed. What if I wanted to print the name of the car? Okay. Simply need to come here and do car name. And if I do cargo run again, this time round we get master, because that is actually the name we given, right? So this time round we get master. So that is how to retrieve, we call it the properties of an object. Okay, so we can retrieve the property name using the dot symbol. So object dot property name, object dot property name for now. I'll be covering functions in a bit. So that's why I didn't want to to hint it. But that is basically it about that. Now, every object or your object may want to have behaviors or methods in this case. Okay, so like in our case car, we can have, or we can give behaviors to our car object, say move, brake, reverse, what else? You know, such things. Okay, so right here, I'm going to show us how we can implement or declare those methods or add them to our car structure, because we don't do it in the same block as other languages. Okay, so I'll come down here and do implement using the impl keyword, and I'm going to implement car structure. And again, guys, if you're coming from a C or C++ background, these should be a breeze to you. I'm quite sure, because you must be familiar with this particular keyword. So down here, I'm simply going to have a method, and I'm going to name it move forward. So again, if you're keen, my method is going to be prefixed to the keyword fn and a space before I give the name. So it's basically a function, but it's a function that is invoked through an object that is going to be created from this particular structure. Now, as it is right now, it is what we refer to as a static function. Okay, a static function is basically a function that can be invoked from the class literal or class name. Yes, from the class name. In this case, the structure name. So this one is going to print. This one is going to print moving forward. Okay. So I said, as it is right now, it is a static method within our car structure. It means we can't use, or there's no single point in time when an object when a car object in this case is going to be able to invoke this function. Okay, here is what I mean. So let's say down here, I wanted to invoke the move forward method, right? Then I want to come down here and do car move forward. So you realize it doesn't even hint it to me in the first place. Okay, it is raising an error. There's no method named move forward found for structure car in the current scope. Okay, let me just make these public, because that is not the right error I wanted. So no method named that found the following associated functions used as methods. Okay, so now you realize that we are unable to invoke that using our car object. But if I did car, so in this case, I'm basically using the structure name car, then instead of the full stop or the dot, I use double full colons. That way I'm able to print or invoke this particular function right here, or the method. Okay, so this is why we refer to it as a static to this particular structure. So if I wanted to make this a method of this particular class, then I'll need to use ampersand self. Okay, and the moment I put that right there, it raises an error right here, and it says that this function takes one argument, but then it got 0 was applied. So in other words, it's unable to find the right match for this particular function signature within our structure. Now, after making that change, I can now comfortably come here and use my car object, then give it a dot move forward. So that way I'll be able to invoke this particular function. And even other than just being able to invoke it from using my car object, I'll also be able to access the object's properties. So in this case, the instant variables of the car object. So I can easily come here and say that give a name of the car that is actually moving. So I can come here and say self dot name. So this should print Mazda is moving forward. Okay, let's just head on to our terminal and try these out. We're gonna do cargo run, and that prints Mazda. So Mazda is what we printed out in line 11, the car name. Then in line 13, we are printing Mazda is moving forward. So this one is coming from the method we just added to our class move forward method. Okay, so this one we passed in the reference to our. So self is what we have in JavaScript as this, the keyword this. Take good note of that, because at some point in time you may get confused and you may find yourself using this in Rust, because this doesn't exist. The keyword this doesn't exist for that particular use case in Rust. So take good note of this self keyword. If you wanted to refer to these instance variable or even the other car methods, then you'll need to use the self keyword. Okay. Now, I just talked about the static methods, or methods that cannot be invoked through our car objects. What are some of the scenarios when we may need or we may require to use such methods within our structures? I'll bring us back to our run function, and you realize there's a way we are creating our object right there as selected. And this is quite strange, so if you're coming from JavaScript and the like, because usually in JavaScript we have a new car, then some curly bracket, you provide brackets, then you provide the parameters that you need to create your car object from. Now, unfortunately, in Rust, our structures do not have the constructor method. Okay, so usually in JavaScript you have constructor method, which basically helps us, create an object using the parameters that we need. So in Rust we don't have that, but we can implement that within our structure. So we're going to use the static method to help us basically put this in place. Okay, I'll just go ahead and copy that because you're basically going to have it inside here. Then I'm going to name this function public new. So new because it's going to create a new object, a new car object. Okay, I'll just give it that name, but you can give it any name you want. So there's no, you're not restricted to just new. Then within new, I'm going to return something of type self. So self means that you're going to return an object of this data type, okay, of a car data type. Then right here, I'm simply going to paste what I copied up there. I'm just going to arrange it well. Then I'm not terminating it at this point, guys. So please take good note of that. I'm not terminating it. Why? Because I'm returning whatever, I'm returning the value that we're actually getting from that. So after doing this, you realize that I have all these values in place. So I don't want to do this. So I can specify these as parameters in my new function. So they're going to come as parameters. So we're going to expect a name parameter of type string, a model parameter of type string, and a mileage parameter of type U64. Then immediately I do that, I simply come right here and do name. Then right here I pass model. Then right here I pass mileage. Okay. Then immediately I'm done with that. So up to that point, I'm able to create a new object or car object using the function new. However, there are some lines or some 3 dots under the name. What are these telling us? Now, if you're coming from a JavaScript and you're familiar with JSON representation of objects, right? So usually if you have a JSON object that has an attribute name and a value that is coming under a parameter under a parameter named name, then it considers this as it's a longhand representation of what you're trying to achieve. So to shorten everything, you can simply use the name parameter name over there. So that way we are still trying to achieve the same thing, but then we've been able to shorten it. Okay. So up here, I can simply come and do car :new. And now within my new function, I'm going to pass all these as parameters over there. Then I can as well carry this as it is as a parameter over there. Then the 2000. Then I'll just do away with this. So this bit, we don't need that. Then I'll just terminate that. So you realize that my program is still working as it should. But this time around, I'm using the new function to be able to construct a car object. So if I head back to my terminal and do cargo run, we still should be able to get the outputs as they were. So Mazda is moving because you are simply able to create an object using that. Okay, so that is basically it. Exit. Awesome. So that is basically it about the structures in Rust. Think of them as classes in other programming languages. So let's move on to traits. Now, what are traits? Traits gives your object interfaces. So think of traits as interfaces in other programming languages like JavaScript. So you're trying to come up with an object or a class, but then you expect your class to implement some interfaces. Okay, sorry, trying to confuse my terms here. So in JavaScript, you're trying to implement a class, but then you expect your class to implement an interface. So there's a way you expect it to be. Okay, so you write an interface separately from your class. Then later you're going to implement your interface within your class. So that is the exact analogy that we're trying to achieve with traits. So we're going to define a certain way our car object should look like. Then while we declare the car class, we'll try to do what? To implement it within our car structure. So let's first of all try to declare a trait. And to be able to declare a trait, we're going to use the keyword trait. And let's just name this a vehicle for now. So inside the body of our trait, we are going to give some methods that any vehicle should have, okay? Behaviors that a vehicle should have. So a vehicle should, first of all, be able to do what? To move. move forward. So that is going to be a function that you're going to be expected to implement within any car structure we're going to come up with. We're also going to have another function, reverse. I hope that is not a keyword. Great. Okay. So you realize at this point, we are only mentioning the name of methods we expect to be implemented in the structure that is going to make use of this particular vehicle trait. Okay. Now, I know we've talked about the car structure previously, so I'll just bring it again down here. So let's say we have a car. This time around, let's make use of just the name, okay? Because our focus is not so much on that. So I really want you, I want to draw your attention in line 20. What we're going to do right here, we're going to implement, okay? We're going to implement using the keyword IMPL, implement the vehicle trait, okay? But this time around, we're implementing it for our car structure. So that is basically how we implement a trait for a structure, or implement an interface for a class in JavaScript. This is how we do it in Rust, okay? So now that we want to implement the vehicle trait up here within our car class, if I have this already captured within my main.rs file, there's some errors you should be able to see right here. So let me just go ahead and do that for us to be able to see them. So I'll go ahead right here and bring in my traits file. Then I'm going to invoke its run function. Great. So if I head back to here, you realize that there's an error. And this error is saying that not all trait items have been implemented within this particular structure. Okay. So it is expecting us to implement all the methods that we listed right here for this particular structure. So that is exactly what I'm simply going to do. So right here, I have the function move forward and the function reverse. I'm going to make them public so that we're able to make use of them. Just have them public. Public. Oh, that is raising an issue. So I'm simply going to give them some statements inside. We'll give it a body. I'll just print some statements right here. So let's print moving forward. And in this case, you're going to, at this point, they are static methods. So we don't want them as static methods. I'll just head back to our trait and make them methods within our class. So let them make use of self keyword. So if I come here and implement them, you realize that they're now taking the self keyword as a parameter. So the self keyword or the self parameter comes the first. If you want to make that particular function a method in that particular class. So I'll just print some statement right here, and I'll name these moving forward. Do moving forward. Then I'll just copy that to the other function, and in this case, we're trying to do what? To reverse. So reverse. We're going to reverse. We're going to reverse self.car. So we're basically going to, self.name. So accessing the name of the particular car that has been created. And at this point, you want to say that, hey, this car is moving forward. Then you just provide its parameter or that value right there. So that is exactly what we've done over there. So we have a trait again. This is the main focus. This is where the main focus is. We have the trait vehicle. We're implementing that trait for our car structure. And within the car structure, this is how we implement that. So we implement the trait by providing the function body to the functions listed within our trait right here. So you realize that here we've just sort of listed them, okay? We just given the function signature in our trait, how it should look like. But what it actually does has been implemented within this other block where we're implementing it within our car structure. So I really hope that is home. Now, if I head on to my run function right here, I'm going to create a car object, and I'm simply going to have this name, then give it a name. I'm going to name this Mazda again. Wait, then terminate that. Now, if I come down here and invoke car dot move forward, then car dot reverse, like that, I should be able to print car is moving forward as the first statement, then reversing or reverse Mazda coming second. So that is exactly what I'm going to run in my terminal. So let's use cargo run. So you realize that we have Mazda is moving forward as the first statement. So that is coming from our move forward method over there. Then we have reverse Mazda coming second, and that is from our reverse method over there. So it again follows how the functions are following each other. So if we had reverse coming first, then I went and executed this again, we would have reverse Mazda coming first, then Mazda is moving forward coming second. Okay, so again, that is how you go about traits in Rust. Now, the last item we are going to cover within this session is what we refer to as the unit tests. So unit test is basically trying to test your program before you actually, before it is officially used or you officially release it for use by users, okay? You're simply trying to write some, give it some, test its functionality, function per function, or, could be a module, whatever. But you're trying to test how it functions before you actually release it. Now, for me to be able to do this, I'm going to avail the tests within our main.rs file. So I'll not work from the test file, okay? I'll not work from that particular file. I'll work from this main file. So we are done with all that. So I'll just work from this main file. Now, the very first thing you need to note while writing your unit tests, now usually they come in the main.rs file. That's why I've decided to put them here as well, okay? Usually, there's this macro we use. So hashtag CFG for configure, then you have bracket, then we pass in test, okay? So that is the first statement. Then we are going to avail our test in a module. And like I said, you use the keyword module, then you give your module a name. So in this case, these are going to be tests. Then after that, you give the body to your module. So this is what you need to note, or something you need to remember before you write any unit test in Rust, unless it is otherwise configured, like we will be looking or we'll be seeing when we start working with the near protocol blockchain. So there are some arguments or parameters we'll need to pass at this point for us to be, because when you work with near blockchain, we want to be compiling this down to the normal bytecode we have been doing, but we'll be compiling it down to a WebAssembly file, which will now deploy to blockchain for us to be able to see how everything is unfolding. Now, within our tests module, we're going to have individual unit tests. Okay. Now, to down here, for me to mark or explicitly notify my compiler in this case that, hey, this is going to be, or this function is going to run a unit test, then I need to use this other macro called test. Then below it, I simply provide the function that I want to run, though that I intend to use to perform that particular unit test. So I'm going to name these check sum. Then I'll simply give it a body, something like that. Okay. And now this is the function that is, and you can have a lot of this function within your file, within your module. It doesn't have to be one. You can have multiple of them, but the name has to be different. So at this point, I already have checksum function. So we can say check add. No, check what? Check division. Something like that, or anything you want to name it. Okay. Again, you're not restricted on the names. You can give it any name you want as long as it achieves what you want it to achieve. Now, there are some other macro that I'm going to mention that are usually used when it comes to unit testing. The first one is Assat Macro. So Assat is basically going to accept an expression that should evaluate to a Boolean variable. Okay, so it will accept a parameter. The first parameter is going to be either an expression or the value that if it is an expression, the expression should evaluate to a Boolean value. And if it is a value, then it should be a Boolean value. Then the second parameter is basically going to be a message. I'll tell you why the message. So this can be an expression, the first parameter, then the second parameter is going to be a string. Now, the other macro we're going to make use of is Assat EQ. Assat EQ is going to, this one basically compares the first parameter. It compares if the first parameter is equal to the second parameter. Okay, so it checks if param1 is equal to param2. If they are not equal, it will raise an error. If they are equal, well and good. The third macro is assat NE, assat not equal. Okay, so this one is assat equal, as this one is assat not equal. Same case right here, assat not equal accepts two parameters, and it is going to check if the two parameters are not equal to each other. So it is going to expect that param1 is not equal to param2. Okay, great. So let's go ahead and make use of these statements. I'm going to start with the first statement. I'm going to assert if 1 plus 1, again, this is an expression, is equal to 2. Then I simply close that. Okay, so our assert is a macro. That's why my analyzer was complaining right there. So up to that point, we have a unit test, or we've written a unit test. So how do we invoke these tests, or how do we run these tests? Something to note is that when you're going to run these tests, your code will not be executed. So whatever you have in your main function will not be run, or will not be executed as we've been doing it before, because you're going to use a different command for this, which is explicitly going to run our tests and not our program, though all these are coming in the same file. Okay, so for us to be able to do that, I'll head on to my terminal. Then you're going to execute cargo tests, cargo test. Okay, so once I execute cargo test, you realize that it went ahead and found two unit test functions. So these checksum and check division. That's why we have two tests right there. The first one was checksum. The second one was check division. Now we have nothing in check division. That's why it is everything is passing right there. But then in checksum, we had some tests and it passed. That's why we have this green indication. Okay. So it is telling us that, hey, your two unit tests passed. So what if I had a different value right here? So I'm trying to check if 1 plus 1 is equal to 11, right? That should definitely fail. So I'll simply come within in my terminal and do cargo test again. So you realize while we were running our program, we were using cargo run. But now that we are testing our program, we make use of cargo test, the command. So really take good note of that as well. And this time round, everything failed, or our checksum test failed. And it failed. So right here, we are told, hey, you had two. Again, I'll begin up here. You had two tests. One was check division, which passed. The other one was checksum, which failed. Now, why did checksum fail? Your thread test checksum panicked at assertion failed. So 1 plus 1 equal to 11 is not true. Okay, so at this point, the value that was returned was false. That's why it panicked. So in Rust, the error, by raising the error, it means that our program panicked. And we have all the details down here. So at this point, we are using Assat to check whether 1 plus 1 is what? 11. Let me just have this back to 2. Now, within that same function checksum, we are going to assert equal. So at this point, you're going to assert if the first parameter is equal to the second what? Parameter. I'm going to assert if 5 is equal to 7. This is false. So our function, or sorry, our unit test should fail. Let's just go ahead and do cargo test for us to be able to affirm this. Great. So right here is the message. So it panicked at assertion left equal to right. So this is what it expects. It expects the left parameter or the first parameter to be equal to the right parameter or the second parameter. But in this case, in the left, we had the value 5, but in the right, we had the value 7. So that is where the conflict came in. And that is what caused our test to fail. So if I went ahead and had both values the same, then did cargo test again, you realize this time round, our check or our test passes, okay? So that again is how we make use of the assert EQ statement. Assert NE, assert not equal. We're also going to test this. Now I'll start with the 5 value, the value 5. Then we're going to see how this is going to unfold. So we expect our test to fail. So anytime you're going to have a series of tests within one function, if anyone or any of them fails, if any of these assertion statements fail, then the whole of that test is going to be considered as it has failed. Okay, that's why you can see I have quite a number of them within the same function. And if one is failing, the whole function has failed. So right here, we also expect this to fail. Let's just confirm this from our terminal. Great. Then I'll just head on to the message right here. It is telling us that it expected the left parameter or the first parameter to be different or not to equal the right parameter or the second parameter right here. So this was this is what it expected. However, the left and the right parameter were all the same. So they were not equal to the other. So that's why it panicked. So if I came here and said 5 and 7, this time round 5 is not equal to 7, then our test should pass. So if I go ahead and do that, you realize that all the tests this time round are passing, okay? But those are just some simple statements within our test module. What if we wanted to test our program? How can we really go about that? Now, I'm going to have a function up here. So remember, this function is coming before our test module. So it's coming above that. I'm going to have this function and I'm going to name it division or divide. Let's use divide, okay? So we're going to divide two numbers. So we're going to have number 1, which is going to be an unsigned, well, let's use I32 for us to be able to find errors as well. Then let's have number 2 as well, taking the value I32. Then we're going to return a value of I32 as well. Then within our program, we're going to do what? We're going to divide num1 by num2. And after the division, we basically return the value. So that's why you're not terminating this right here, guys. So we expect, now any number divided by, is it a 0 divided by a number or a number divided by 0 where we have an error? We're going to find out within our test. So I basically have this function within my main program, and I want to be able to test it. So I don't want to run it, okay? I could as well just come here within my main function and just invoke it inside here. So let's go ahead and do that. So let's say we have 25, then we have 5 at that point. Then we are storing this value in some result variable. Then down here, we're basically printing it out. Okay, so we're basically saying division, then passing in the value in our result variable. Then I terminate that as well. So if I use cargo run, I think I've not terminated line 9, so that's great. So if I go ahead and run this particular program, I do cargo run, this is going to run this particular statement. And what is going to be printed out is 5, okay? If I used 0, let's see what will be printed out. So at that point, our program panicked, okay? It panicked and it said, we are trying to divide, so a number cannot be divided by 0. So that's why we are having this error being raised, okay? Now, instead of us doing our program and seeing that everything is working well, because these are some things you may not expect within your program. These are runtime errors. These are errors that can be caused during the runtime of your program. So from your end, you might have done everything and just feel like everything is working well. So for us to be able to test this, even before we deploy our program, we need to test the functionality of our function. And we're going to do that within our unit test section or module down here. So here, this method called check division is where we're going to perform our check. And the very first thing I'm going to do is import this function within my test module. Okay, so the very first thing I'm going to do is make it public, make the function public. Then down here, I'm going to import it using the use keyword. So I'm going to use super again, because they are all in the same file. Then within super or within the main file, I'm basically going to import everything. So that's why the asterisk is there. Awesome. After we have that in place, what is this? Now, after we have that in place, it means that we can now use our divide function. Let me head back there. Yeah, it means that we can use our divide function now within our test, within our unit test function. So inside here, I'll simply come here and do assert. So we're going to assert that our divide. So let me just create another variable inside here, call it res. Then I'm going to invoke our divide function in our main. Sorry, I'm going to invoke our divide function up here within our test function. So I'm going to divide 25 with 5. Okay, so that is basically going to return some value which we're going to store inside our res variable. And so I'm going to test if this variable is equal to 5, because if you do 25 divided by 5, you should get 5. So I'm simply going to check if our response is actually equal to 5. If that is not, then it means our test failed. So we're simply going to give some custom message at this point, and we're going to say that our division failed. Then I terminate that. Okay. Now, if let's go to the head on to the terminal. If we run this, it should pass. If I run that, no, I did cargo run. I need to do cargo test. Sorry for that, guys. Cargo test. If I do cargo test, you realize that all our unit test passes. What if we had a 0 right here? Then we go ahead and do cargo test. Now at that point, it panics or it failed because 25 divided by 0 was not equal to 5. It actually panicked. And the message is right here. It is saying that it panicked at here, attempt to divide by 0. And where is our custom message? Trying to check for the custom message. So the panic we just received was from the function itself. It was not within our test function. Let me just change that. Again, there's a reason, there's how you can go about that, guys. Let me do test, not run. So at this point, it failed, yes, because 25 divided by 1 is not 5. So that's why our test failed, and it's coming with our message right here, division failed. So we have these, this was the custom message we passed up here, division failed. So it's giving us some description of what error we are trying to get within our program. So at that point, it failed. I can still use the other statements. So we can assert that the response is equal to 5. Okay. We can as well use this statement. Let me just comment out this for us to focus on this. So if I use the statement assert equal, then I execute cargo test. Then you realize the test passed. Why? Because after dividing 25 by 5 and storing the value 5 in our res, it asserted that the value 5 is actually equal to what? To 5. So that's why our test is passing. So again, guys, that is basically how you go about doing your unit tests in Rust, and write your program, test your program before you can actually deploy. Now, there's a reason why we are covering tests when it comes to programming or doing your smart contracts on any blockchain in this case, because one quality or one property of a blockchain network is that once you deploy now, first of all, every transaction on blockchain is paid for. There are rarely free transactions on blockchain. Rarely. They could exist, but they're very rare. So most of these transactions are going to be paid for. And if you're going to deploy a file, now the first property I talked about was the transaction bit of it. Now, the second one is once you deploy anything to blockchain, it is going to be immutable. Like you can't just go like any other software. Let's say you are a web developer, then you've come up with a website, you've done your website the way you wanted, you've deployed it to a hosting company somewhere, but then you realize there's somewhere you made some error. So you go make the change, then try and go and deploy again for you to effect the correction. Now in blockchain, you can still be able to do that, but then you're going to pay some money, or it could as well be impossible depending on the blockchain network, the way it has been engineered. So that's why we have unit tests in place so that you're able to test your program, test your software, test your smart contract, and establish that actually everything is running as expected, or everything is executing as you expect. Then after that, you can now be able to deploy what? Your final product, or what you're satisfied with on a blockchain network, and be able to use it, or expose it to the whole world to use it.